Santham Academy. Welcome to Digital Kaksha. To get updates on new videos, click the subscribe button and the bell icon.
Hello students, today we are going to study the third chapter of NCERT, that is current electricity. Current electricity is the study of the electric charges when they are in motion. As we know that in case of a conducting wire or a metallic wire, the free electrons which are present are responsible for the flow of the current when across the ends of that wire the potential difference is applied. In this diagram, here it is representing a wire which is connected to the positive and negative terminals of the battery of potential difference V. We have considered the length of the wire to be L and its cross-sectional area to be A. The dots inside the wire are representing the free electrons which are present inside this conducting wire. The direction of the current, it is also mentioned in the circuit diagram, that is from the positive to the negative terminal of the battery. Now, what is the meaning of the term electric current? So, electric current, it is a physical quantity which is given by the formula Q upon T and is defined as the rate of flow of charge. Certainly, when here it is a closed circuit, the free electrons which are present inside the conductor experience the force of repulsion from this negative terminal of the battery and they are forced to move towards the left side of the conductor. So, here the free electrons are the charges which are flowing inside the conductor. So, let us come to the definition again. The electric current is defined as the rate of flow of charge. Since the charge is also given as N into E, so the N here it is representing the number of electrons present in the wire and E is representing the charge of one electron in the wire. The SI unit of this physical quantity electric current is ampere, which is denoted by capital A. The device which we use to measure the current in the circuit is called as ammeter and the symbol of ammeter is capital A, which is encircled with the positive and negative signs. Now, when these are the electrons which are in motion in a specific direction, there are n number of electrons which are present inside this conductor. So, for all these electrons, we have to study a term that is known as drift velocity. Let us understand now what is the meaning of the term drift velocity. The standard notation for this physical quantity is V and D is to be written in the subscript. Now, when these many electrons are there, we can get the value for the velocity of every electron after the application of the potential difference. What do I mean by saying that? When a piece of wire or a length L of the wire is given to us, in that wire also the free electrons are present. But in the absence of the connection of the battery or in the absence of the physical quantity potential difference, all those free electrons have the tendency to move in the random direction. That velocity value for those free electrons before the application of the potential difference can be considered as their initial velocities or even the thermal velocities. Now, in order to understand the term drift velocity, after connection of the battery and after providing the potential difference to this conducting wire, all these free electrons are forced to move towards the left end as we have discussed just now. So, in that case, the velocity with which all these free electrons will move, that velocity can be considered as their final velocities. We know the relationship between the initial and final velocity of any of the object using the first equation of motion. One more thing is to be understood here, that when large number of free electrons are present inside the conductor, certainly when their motion will start, many of the electrons, they will collide with each other. Between the two successive collisions, certainly there will be some time elapsed. That time which is elapsed or that time which is passed between the two successive collision of every electron also has to be taken into consideration. So, the first equation of motion will allow us to relate all these quantities with the help of the standard formula for first equation of motion, that is V is equal to U plus AT. We have talked about the final velocity, initial velocity and this time. We have to understand that what is this A representing here. So, this A is the acceleration of the electron which is coming into existence because every electron is experiencing a force. Now, what is the factor which is responsible for providing the force to the free electrons? So, when we have connected the battery, certainly the potential difference is existing between the two ends or the two terminals of the battery. Along with that, there exists the electric field also, which is directed from positive to the negative side, or even I can say from left towards right side. So, every electron is experiencing the force in the presence of this electric field. As we are already aware of the formula of the force experienced by any charge due to the electric field, that is given by F is equal to Q into E. Since the charge of the electron is represented by small e, so this formula in this case can be written as F is equal to E into E. So, this way, in the first equation of motion, we have understood that what are the representations of all these four quantities used in the formula. Now, in order to derive the formula for the drift velocity, we will be using this first equation of motion individually for the n number of free electrons which are present in this conductor. So, for that, I can write the equation for V1, that is for the first electron's velocity, as U1 plus A tau 1. Here you can notice that no subscript is written for A because each and every electron will be accelerated by the same force, and that acceleration can be given as A is equal to F upon m, where m is representing the mass of the electron which is constant. Also, the value of force given by E into E is also constant for all the n number of electrons. Here, tau 1 is representing the relaxation time, that is the time taken by the electron between its two successive collisions. This way, the equation can be written as for the second electron and can be continued up to the n number of electrons. Now, let us come to the definition of the drift velocity. Drift velocity is defined as the average value of the velocity of all the free electrons. So, here in order to get the formula and the mathematical representation for VD, I can write the formula as VD is equal to V1 plus V2 up to Vn upon n. That is, I have taken the average value of all these calculated values of the velocity. Here, after this step, I will substitute the values of V1, V2 up to Vn from here, and with the separation of the terms, I can write this equation in this manner, that is u1 plus u2 up to un upon n plus a into tau 1 plus tau 2 up to tau n upon n. Now in this case, the first term on RHS is representing the average value of the thermal velocities of all the free electrons, means this is the average value of the velocity of the free electrons before the connection of the battery or before providing the potential difference to this particular wire. Because of that, since before connection all the electrons were moving randomly in any of the directions, that is why the average value of this thermal velocity of all the n number of electrons comes out to be 0. And this term, in second term, the term which is written in the bracket, that is tau 1 plus tau 2 up to tau n and is divided by capital N, is representing the average value of the relaxation time for all the free electrons. So, after understanding all these things here and after substitution of the values which we have discussed on RHS, the value can be written as Vd is equal to A into tau, where tau is the average value of the relaxation time. Now, from here we are knowing that the value of A is equal to F upon M, which can also be written as EE upon M. So, this value of Vd can be written as EE upon M into tau. We also know the relationship between the electric field and the potential difference which is applied. That is, E is equal to V upon L. Now, when this value I will be substituting here in the formula, I will get the formula for the drift velocity in terms of the applied potential difference, and it can be written as E V tau upon M into L. Coming to the next topic, that is current density. This physical quantity current density is defined as the current flowing per unit value of the cross sectional area of a given conductor. Here if we are considering a conductor, this conductor, let us take the length of the conductor to be L and its cross sectional area to be A. Certainly, when the current will enter in this conductor or the wire, so in that case it will flow through this cross sectional area. So, the formula for this physical quantity current density, which is represented by capital J, is given as J is equal to I upon A. This current density, it is a vector quantity, and the SI unit for the current density is ampere per meter square, as it is clear from the formula. Now, let us talk about the wire and what will be the resistance. As you all know that resistance is the obstruction offered to the flow of electrons inside the wire. So we have to study about the factors affecting the resistance of a given conductor with the dimensions L and A. Let us now discuss about the relationship between the current and the drift velocity. In order to get this relation, we will be using the formula for the current, that is equal to Ne upon T, where N is representing the total number of free electrons which are present inside this wire. In this case, this capital N are the number of electrons which are present in the given volume of the wire. Now here, what is the volume of the wire? So, since we know that the wire is of the cylindrical shape, so the formula for the volume of the cylinder is pi r square h. Now, in this case, for the wire, A is the cross-sectional area. So, the formula for the wire's volume can be given as A into L, which can be represented here by capital V. We have to introduce a new term here, that is number density. Number density, it is the physical quantity which is denoted by small n and is defined as the number of electrons per unit value of the volume of the wire. So, mathematically, I can write small n to be equal to capital N upon AL or even capital N upon V. This physical quantity, number density, has got its unit per meter cube or meter to the power minus 3. Now, how we have to use this concept of number density in this formula? For that, here capital N, it is representing the number of free electrons which are present in the wire. I can express this capital N in terms of this small n. In that case, how I will be expressing this capital N, which can be written as small n into V into E upon T. Further, I can be written as small n into, in place of V, I can write the given dimensions of the wire, that is A into L, E as it is, divided by T. In this formula, I can say that L divided by T will provide me the dimensions of the velocity. The velocity which we here are talking about is the average value of the velocity of all the free electrons. So, using this concept, in place of L upon T, I can substitute the value of drift velocity, that is Vd, and this E is to be written as it is. When I will rearrange the terms, I will get the formula for I to be NEAVD, where this is the formula for the current in terms of this drift velocity.
Thanks for watching. If you like this video, make sure to like, share and subscribe for more.